Hello and welcome. This is going to be our lecture video for February 1st through 2nd. Let's go ahead and get started with a quick do now. Here I've got a bunch of numbers. I want you to find the reciprocal of each of the following fractions. So a reciprocal is, most simply put, is a fraction flipped upside down. So in your notebook, we're going to try to find the reciprocal of all of these fractions. So 3 over 4, easy enough. We just flip that upside down. That's going to become 4 over 3. Negative 2 over 3. Flip that upside down. But one thing is with a negative, we always want to bring the negative back to the top. So we'll make this negative 3 over 2. So negatives can move between both sides of a fraction. All right, 7 over 6, I bet you can get this one on your own. It's 6 over 7. So notice when you start with a proper fraction, you end with an improper fraction. When you start with an improper fraction, you end with a proper fraction. All right, but what do we do about this one? Just a 4. Well, here's what we're going to do. We can turn any 4 into a 4 over 1, and that's still equal to 4. But now this can be flipped upside down, so now this becomes 1 over 4. Well, what about 1? The reciprocal of 1 is just 1. So that's the only number whose reciprocal is itself. Well, I guess negative 1 would also. So 1 and negative 1 are the only numbers whose reciprocals are themselves. All right, and what do we do about this mixed number? Well, we got to convert this back to an improper fraction, and then we can find its reciprocal. So to do that, I do this little swoop around like this. So I do 5 times 2 plus the 1. 5 times 2 is 10 plus the 1 is 11. That means I can turn this into the improper fraction 11 over 2, which would then give us the reciprocal of 2 over 11. Now let's talk real quick about why reciprocals are useful. All right, write this down. Whenever you multiply a number by its reciprocal, you get 1. So let's test that out real quick. Let's do our very first one, 3/4 times 4/3. So 3/4 times 4/3. When we multiply fractions, we multiply straight across the top and straight across the bottom, so we get 12 over 12. 12 divided by 12 is 1. All right. Goal for today is to be able to identify when two lines are parallel or perpendicular. Why? These are some of the most common relationships between two lines, and are very important to architecture and design. If you're designing a building, you want to make sure your walls are parallel to one another. All of your corners are nice right angles. That means that they have to be perpendicular. So very important relationships. Let's start by talking about parallel lines. Draw a quick sketch like this. The most important things about parallel lines is that they stay the same distance apart. All right, they never cross. And then, mathematically speaking, they have the same slope. And we can get that from this picture here. Let's do a slope triangle on both of these. So I can connect 2 points, and any 2 points should give you the same slope. All right, rise over run, so the rise here is 2, the run here is 3. The rise over run for this line is 2 over 3. All right, let's pick a different spot on this line, but as you can see, these slope triangles are already congruent. So it's going to give us the same slope. Rise is 2 for every 3 it runs. And this should make sense because slope is independent of the y-intercept. All right. So they can have different y-intercepts if both slope and y-intercept match, the lines are, and here's a new vocab word for you, coincident. All right. So would two lines going through the following points be parallel? Copy down these points real quick. In order to find out, we have to see if they have the same slope. All right, so line 1, I'm going to label it x1, y1, x2, y2. Then plug it into my slope formula. M equals y2 minus y1 over x2 minus x1, which equals 5 minus 3 over 0 minus a negative 4. Don't forget the minus from the formula and from the point. This here becomes 2 over 0 plus 4, so just 2 over 4. And I can simplify that by dividing the top and the bottom by 2 to get 1/2. All right, line 2, same thing. x1, y1, x2, y2. y2 minus y1 over x2 minus x1. Again, we have a double negative because there's a minus in the formula, plus x1 was negative. So this becomes 4 over 6 plus 2, which becomes 4 over 8. This can be simplified by dividing the top and the bottom by 4, and we get 1/2. So these match. So yes, they are parallel. You would then have to compute the y-intercept if you wanted to see if they were coincident, but they are definitely parallel. All right, what about these two lines? Are these parallel? So again, we're looking for same slope. All right, and to figure out what the slope is from an equation, you have to figure out what value is in the position of m in y equals mx plus b. So m is your slope. So for line 1, it's really easy to tell that 3 is the slope. M equals 3. But line 2 is a little bit more difficult. Which of these numbers is the slope? Well, we have to convert it into this form to be able to tell. So let's try that right now. Let me copy it down. All right, I need to get y by itself, so I got to get rid of this divide by 3. So I'm going to multiply everything by 3. And now I've got negative 9 equals 3x minus y. All right, I still want to get y by itself, so I'll add y to both sides. And now I've got y minus 9 equals 3x. And I'll add the 9 to both sides, and I get y equals 3x plus 9. So these are the same equation. It's just been manipulated using inverse operations and the balancing method. So this is an equivalent equation, and its slope is now much easier to see. We can see that m equals 3. So the slope of this is 3, the slope of this is 3, and the slope of this is 3. So yes, these are parallel as well. Okay, perpendicular lines. Here we've got an example of two perpendicular lines. So what is special about perpendicular lines? They intersect at 90 degrees. So this angle that they form is 90 degrees, and when it is 90 degrees, you put a little box there. You can label it 90 degrees if you want to be just extra thorough. And if that's 90 degrees, then all four angles are 90 degrees. So it's 90 degrees all the way around. All right. And then the y-intercept can be same or different. But then most importantly is the slopes are opposite reciprocals. So reciprocals means it's the same fraction flipped upside down, but opposite means if one is positive, the other is negative. All right, so let's come up with some examples of opposite reciprocals. The opposite reciprocal of 1/2 would be, you flip it upside down, you make it 2/1, but then you have to make it opposite, so this was positive, so now it's going to become negative 2/1, but then this can be simplified to be just negative 2. So the opposite reciprocal of 1/2 is negative 2. What about 7/8? Well, this just becomes negative 8/7. So there I flipped it upside down and made it negative in one step. What if I start with something like negative 3? If I start with something like negative 3, I'd want to turn it into the fraction negative 3/1, then flip it upside down, get negative 1/3, and then I can make it opposite, positive 1/3. All right. So, would two lines that go through the following points be perpendicular? So, we got to label them, and we got to find the slopes, because we got to see if the slopes are opposite reciprocals. So, x1, y1, x2, y2. Plug it into our slope formula, y2 minus y1, watch out for the double negative, over x2 minus x1, again a double negative, this becomes negative 2 plus 2 over, no, I feel like I made a mistake here. No, I didn't. I think I might have meant for one of these to be positive, but let's just go with the numbers that we've got. So now I've got 1 plus 3 on the bottom. I get 0/4, which is just 0. Let's try it with this one. Change colors real quick. x1, y1, x2, y2. 2 minus a negative 2 over 3 minus a negative 1. And we get 2 plus 2 over 3 plus 1, which equals 4/4, which equals 1. 0 and 1 are not opposite reciprocals. So these are not perpendicular. All right, I don't think I meant for that to have a slope of 0, but let's talk about that real quick. If we have a slope of 0, that would be a horizontal line. So this has slope 0. A line perpendicular to that would be a vertical line. So horizontal and vertical lines are perpendicular. But this one has an undefined slope, so we wouldn't be able to write an equation for it. Slope is undefined. So in general, perpendicular lines have opposite reciprocal slopes, except for this one very specific example with a horizontal and a vertical line in which the slopes are 0 and undefined. Okay. I think I meant to say, are these two lines perpendicular? Why don't you copy these ones down? All right, so neither of them are in slope-intercept form, so I can't tell what their slopes are. I need to get them into this form so I can compare their slopes. So let's practice that right now, starting with line 1. I've got, I'll do it over here, 2x plus 3y equals 3. I need to get y by itself, so I subtract 2x from both sides, and I get 3y equals negative 2x plus 3. I divide everything by 3, and I get y equals negative 2 over 3x plus 1. I distributed that division there. And all that really matters is what that slope is. The slope is negative 2 over 3. All right, now let's try that with this other one. So now I've got 3x minus 2y equals 4. Again, I want to get y by itself, so I'll move the 3x to the other side. Negative 2y equals negative 3x plus 4. Always put it in front of the constant so it looks more like mx plus b. Divide everything by negative 2. And we get y equals, the negatives cancel out, and I'm left with 3 over 2x. 4 divided by negative 2, we'll distribute that division, we'll get a negative 2. But again, all that matters is that slope, m equals 3 over 2. And here these are opposite reciprocals, 3 over 2 and negative 2 over 3 are the same fraction flipped upside down. One's positive, one's negative. So yes, perpendicular. Okay, that's the end for this lecture video. I'll embed a few more here, and have a good rest of your day.